Good afternoon, friends. Welcome back to the webinar of Gen AI. Today, again, we meet with an interesting topic, which is self-consistency prompting. Okay? So, we've been discussing a lot of prompting techniques. We've discussed in the past React prompting, few shot prompting, zero shot prompting, chain of thoughts, etc. Today, we're going to Today we're going to start off with self-consistency prompting. This is technique by prompting the large language models to improve the reliability and correctness of their answers, especially for reasoning based or complex tasks. What exactly is the self-consistency prompting? In standard prompting, the model is asked to answer, is asked a question once, and it gives a single answer, isn't it? But in self-consistency prompting, it's a little different. The model will be prompted multiple times. We use something called as temperature sampling. You will keep prompting multiple times in order to generate diverse reasoning paths. And then the most common final answer among all of these paths will be selected. So it's like repeatedly you're prompting by changing the temperature parameter value and increasing temperature parameter value, decreasing the temperature parameter value, you'll generate several responses. Finally, whichever is the most common path or what most common answer, that path will be selected. So why exactly are we using the self-consistency prompt and when do we require it, right? So LLMs might sometimes make certain errors while doing reasoning tasks. So even though they look very confident and they seem very confident, sometimes they can hallucinate and sort of make certain small mistakes when it comes to reasoning, right? So self-consistency prompting will help you reduce these kind of hallucinations, and it will encourage multiple reasoning paths. It will basically aggregate these parts in order to find a particular consensus answer, right? A final answer which is probably the right answer. Now, filter and it will also filter out the outliers and incorrect responses in this process. Now, how exactly does this self-consistency prompting work? So, if we ask the same question multiple times, for example, I ask the question to ChatGPT or LLM, the very same question I keep asking multiple times. Each time with randomness, that means each time if temperature value is greater than zero, we keep on getting different reasoning paths. Then we will parse the final answer from each reasoning chain, and ultimately it will pick up the most frequent final answer as the output. Let's take an example. Let's say that we are asking a question, what is the sum of the first 10 odd numbers? Model can give multiple responses. Model can say random samples with different reasoning. For example, the first 10 odd numbers are 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. It can add all of them and say this is equal to 100, or it can say sum of odd numbers up to 10. We ask the question, sum of first 10 order numbers. It is saying, okay, what are the sum of odd numbers up to 10? And it's adding 1, 3, 5, 7, 9 and giving the result as 25. Now that's the wrong answer. Then it can also prompt itself saying that, hey, the nth odd number is 2 and minus 1. So sum is equal to n square, which is equal to 10 square, which is equal to 100. Right? Or it can say using the formula n square is equal to 10 square is equal to 100. Or it can say I'm listing and adding and output is 100. So majority of these paths are saying 100. That is self-consistency prompting. So we have eliminated the outlier, which is summing 1 plus 3 plus 5 plus 7 plus 9 and telling that the result is 25. Rest of the uh, reasoning parts are giving a separate answer 100. So it will go with what the majority says. When do we use exactly this self-consistency prompting? When you need math and logic reasoning, when you need some common sense question and answers, when you want multi-hop reasoning, even when you want to perform chain of thought prompting tasks, we will go with this self-consistency type of prompting. Self-consistency prompting will typically outperform the greedy coding in tasks which need step-by-step reasoning. It requires more computation, so multiple passes will be there. And it is often used along with, or it is often paired with, we can say, chain of thought prompting technique. So instead of using it alone, we use it as a combination with chain of thought prompting technique. Now, let's try and understand the code given here. For self-consistency prompting. The first thing that we're doing is installing the required libraries. So transformers, accelerate, and sentence piece. Transformers for working with Hugging Face models, auto tokenizer and auto model for casual LM, which will automatically it automatically basically loads the model and tokenizes for text generation. Counter will help you count most of the answers, most common answers it will count. And then you have torch, of course, because you're going to get into basically it is required for running the models either with GPU in Falcon 7 Falcon model, which was trained on 7 billion parameters. Okay, this instruct model. Then I have tokenizer, which is going to break the test into tokens. The model will understand. And torch dot float 16. This will use less memory if you have a GPU. Then we're mapping the device to order. So it will put the model on GPU if it is available in case. Then the third thing that we're doing is prompt template. We're defining a chain of thought format prompt. There we say that build a prompt such that answer the question step by step. Right? So give me a detailed step by step answer to the question that I'm asking. And then finally, we're trying to generate a response. We're saying generate a response by question, uh, taking the question. Question is nothing but answer step by step. And temperature value that we have given is 0.7. A moderate temperature value is what we have set here. Then so basically we are building the full prompt. We are going to tokenize the input, convert text into some numbers, and we will use the model to generate. So when we say do sample true, it will enable random sampling instead of greedy output. Temperature 0.7, when you set the parameter to 0.7, it will add controlled randomness. Higher the temperature value, more is the diversity of creativity. Always remember that. Then we can say maximum tokens is equal to 256. This is the maximum length of the response. We're limiting it to response length to 256 because that is what the Falcon model can take. That's the limit. And then finally, we will decode the tokens back to text and return just the generated part, excluding the prompt. That's exactly what we're doing here. We're just skipping the input part and giving the output. Then we are going to say extract the final answer. In order to extract the final answer, it will look at each line in the response. If it finds a line link final answer 100, it will extract as 100. Otherwise, it will return back the last line as a fallback. Then we have the self-consistency loop or the self-consistency process itself, where you are putting in a for loop, right? This will repeat the prompt number of sample times. For example, here, what is the number of sample times we have given? Maybe we can give 5 times as a number of sample times. It will gather all final answers. It will print each response and the extracted final answer. And then it will use the counter to find the most frequent answer. That's what the self-consistency answer will do. Then we are going to run the full process. That is, we'll ask a reasoning question. We will get 5 diverse answers and it will pick the most frequent one. This is how the model works. Self-consistency prompting, we're using that in combination with chain of thought. Now, in this particular code, you can actually start experimenting. You can use different other models instead of, I have used Falcon 7B instead. You can also replace this. Maybe you can use Mistral 7B instead of that. Then you can also get into maybe using Zephyr model, which is again trained on 7 billion parameters. Zephyr 7B beta model, that also you can fetch. Basically, you can go look for open source models within Hugging Face, which do not ask for an open API key. And with that, you can start off with your experiment. So this is all about self-consistency prompting, where we are pairing it with our chain of thought prompting to get the most frequent final answer. That's how the prompting technique works. That's it for today, guys. Maybe next time we'll meet again. A couple of more prompting techniques to go, and then we'll switch over to orchestration phase. So please stay tuned in. Meanwhile, you can subscribe to our 360DigiTMG channel. And if you have any doubts, any feedback, any comments to share, you can drop it down in the comment section. Don't forget to subscribe to us. Thank you.